Welcome back, everybody. I'm back on this project here. I took these rotors apart. Well, actually, I've only taken the one apart. The other one's still sitting in the corner. I wanted to see where this one went before I disassembled the second. And you guys saw all that. It was a lot of rivets to drill out. Next one will go a lot easier. I learned a few tricks along the way. And basically, as you guys know, the previous owner had overbent this by a few degrees. And I've been wrestling back and forth in my mind as to whether I could bend that back or not. I know that 6061 does not like to be bent in two directions, but it was only a couple of degrees. So I've been wrestling with it and I figured I'm going to try and bend this one back and see what happens. It wasn't that hard. Actually, what I did, I didn't think to film it because I kind of thought I was going to break something, which would have made for a good video, but it wasn't very dramatic at all. I took it down to the machine shop, and on one of my mills, I have a 6-inch wide Kurt vise, and I threw in some aluminum soft jaws, taller ones, about so I dispersed the weight over the entire width of the hockey stick. And then on top of that, at the points of contact at the corners, because the back jaw will be pressing against the lower part of the V here, and then at the points of contact on the front, I took some more scraps to not have the corner of the soft jaw digging directly into anything, so I displaced that pressure with other scraps. So there was no single point of contact on the hockey stick at all, except for the straight up and down vertical in the rear, which is the part you really want supported. And then what I did is I just slowly cranked in the vise and closed it to take some of the bend out of the hockey stick. And I flexed it in and backed it off, and it would spring back. And I took it off, put it across the mill table, made sure the level was 0, checked the other angle, barely moved it at all. So there's a great deal of springiness in this material, believe it or not, which is a good thing, because when things flex, they're less likely to break, which is kind of what I was hoping for and counting on. So I repeated that procedure, I think, about 4 times, and on the last go, I cranked it in a little bit more than I really thought I should, and backed it out, and again, it flexed back out quite a bit. Threw it on the table and zeroed. Now, I'll show you what it is. So basically, zeroed out the gauge like that, and then at the same time, put it up parallel to the bend line, and basically I slightly underbent now, probably about half to 2/3 of a degree, and I think that's okay. That can be displaced with the tightening of bolts and things like that. You can keep trying to bend this to get it to exactly 20 degrees, and I think you're just going to do more damage than good. Thoroughly looking over the piece, top to bottom, and definitely want to make sure there's no structural fatigue. And I may very well even just call around to some of the local machine shops. I remember back in the day when I used to build more engines and stuff like that, they had magnafluxing, which they technologically sort of like add a dye to the metal, and they can kind of look at it under light and see any fractures. I don't know if that can be done with aluminum the way it is on like cast iron blocks and stuff like that. But just so you know, before I go sticking this back into the rotavator and the rotavator then on the plane, I'm going to do my best to talk to people way smarter than me and hopefully even have this professionally looked at by somebody that may be able to look for or measure any fatigue in the metal, because we certainly don't want that. And they're not that expensive. I think they're like $160 a piece. So there's still a chance I just buy 2 more and try and bend them right from the beginning. But with the wait times for everything these days, I'm just as impatient as the rest of you. So I honestly think this is definitely good enough in my mind. But again, I'm not an expert, so I'm going to talk to somebody who's smarter than me, maybe a couple people, and get that taken care of one way or the other. Now, the rest of the rotavator, there really was very little damage in drilling out the rivets. Some depressions around some of the rivets, not that big a deal. I could take a small body hammer and dolly and kind of flex them back to flat. And there is a couple of holes, I want to say only 2 that I can think of, that are elongated or oblonged or maybe oversized. Almost everything else looks fine. I'm going to grab my calipers real quick and get you an accurate measurement. Okay. All right, so any one of these holes is generally going to be right in the 145 thousandths range. Now I have this one here. I have one hole that is still the proper width, but it got elongated roughly 0.24 inches, which is, it's almost 1/10 of an inch elongated. And now it's only one rivet out of pretty much 100 rivets on each side of this. It's not along a rib. Obviously it goes across the spar part, but I don't think that is worth replacing the entire skin over. Because other than that one, it doesn't look bad at all. Like I said, I don't know if you can see any reflections where a couple have just become dinged a little bit, but that's all easily fixed. So I think that I can take that one rivet and drill that out oversized, substantially oversized, because now I've got to come up to at least 3/16 rivet, possibly even a 1/4 inch rivet in that one hole. I will talk to Carrie at Sonex and see if that is acceptable or not, seeing how it is one. Like I said, I might have found another one that wasn't that bad. That was definitely the worst case out of all of them. So I figure one out of 200 plus, not in a, where a rib meets a spar or anything like that. I don't see that being a huge problem. I've gone so far as to think about, I don't know much about welding aluminum, but I know people that are smarter. I don't know if I could take this down to a friend and have them kind of just weld in a little bit of material there and then re-drill the hole to proper size. I'm not sure that's an option. If you're smarter than me, or if you know more about that particularly, I don't know if 6061 is weldable. I'm sure it is. Everything is weldable one way or another. But I have a TIG downstairs. I can do some TIG welding, but I definitely wouldn't, try something like that on my own. So if you know, or you have an obvious answer to that question, let me know. I'm going to call around and see. If not, like I said, I think one oversized rivet in the whole renovator is not the end of the world. In fact, it's a stronger rivet. So might look a little weird to have one oversized rivet, but that's not all that important. So now that I have gotten this one taken care of, and I'm fairly convinced that the hockey stick's fine, I'm fairly convinced I have a valid solution for the one or two random holes in the skin that look a little bit off. Now I'm ready to go back to the other renovator. I will start taking that one apart. I will see if that is farther out of spec than this hockey stick. If it's much farther out of spec, I won't try and bend it back. But this one here, like I said, it was 2.5 degrees to 3 degrees. And it was bent at a little bit of an angle. So one side was bent out a little bit more than the other. But the way I corrected it seems to have brought it really close to spec. Like I said, 0.5 degree. I don't think anybody in the world could complain about 0.5 degree when it comes to something like this. So I'm going to get to work on taking the other renovator apart, and I'm sure you don't want to see me drill a couple hundred rivets again, so this will be a really short video. Thanks for tuning in as usual. If you like what I'm doing here, hit the subscribe button. Definitely the thumbs up, because YouTube really loves that. And then share these videos with your friends. Thanks for watching.